Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Muin bin Abdul Aziz, Bachelor in Mechanical Engineering, EM 220, Semester 8. Today I'm going to present my final project, which is Energy Modeling of Cooling System at UiTM Academic Building. So we're going to move to the next slide, which is objective. So the first objective is to determine the energy consumption HVAC on academic building in Malaysia. The second objective is to evaluate the proper ducting design that affect the energy consumption in academic building. The scope of work, we have 5 scope of work. First is the academic building. The first one is to investigate which system contribute the most energy consumption in academic building. As I have mentioned before this, 57% of energy consumption in a building is HVAC system. Second one is library. After we have secured the library layout, we will study the baseline HVAC system, such as type of HVAC and also number of air handling unit. The third scope of work is air flow rate, which is many factors have contributed to energy consumption of the HVAC system, as well as the air flow rate along the duct and fan power. Next, last but not least, run simulation using IESVE software. IESVE will compare the baseline model with the new ducting design. So let's go to the methodology. So the first methodology is there's 3 phases for this project. The first phase is phase 1, HVAC system. Investigate HVAC system and then select the suitable parameters. Last, research on air handling unit. For the phase 2, it will be the ducting operation analysis, IESVE analysis on air flow rate and fan power, and then we set acceptable parameters. Last, determine the air flow rate on ducting system. The last phase, phase 3, is energy modeling. Improve on the modeling and then determine the energy consumption. Okay, we're going to the flow chart. So in this flow chart, there's three stage. So the stage 1 is the investigate the problem. So we will investigate the performance of the HVAC system. We're moving to the stage 2, improvement on HVAC system. The design HVAC system. First we will design the HVAC system and then improve the HVAC system by air flow rate and fan power. And then we will design the HVAC system by our software IESVE. And then we will improve the design to reduce the consumption. Let's say if we're not satisfied with our improvement, we will do it again at the improvement of the design to reduce energy consumption. And then if we're satisfied, we will move to the stage 3, which is energy modeling. And then that's the end of our project if we have satisfied with our improvement. So let's go to the next slide, which is geometry. This is our geometry of the library. The library geometry is created using model 8. This is the two-dimensional geometry. The area of the library will be 168.525 meters squared, and the volume will be 13484.2 meters cubed. So this is the parameters for this project. There's 2 keys. So for the first case is constant flow rate, which is 1011.52 from ASHRAE standard, and the fan power 0.7 and 0.55. So for the second case, the constant will be the fan power, which is 0.55 kilowatt from the catalog, 1011 flow rate, and 1023.61. Okay, so we go to the next slide. So we're moving to Apache HVAC. So this is the template of the ASHRAE standard 62.1 2019. So this template will we need to use to find the minimum ventilation rate in a building. So as we can see there, we can find the library, which is 0.6 liter per second meter squared at the area outdoor air rate, and we will multiply with the area of the library. So we will get the minimum ventilation rate in the library. So the other template table, is a catalog from manufacturer. So for this template, we have the minimum airflow rate. And then we will compare it with the fan power, which is 0.55. In the ASHRAE standard, we have the airflow rate, which is 1011.52, and the fan power is 0.7. For the manufacturer, in the catalog, we have the 3,800 meter cube per hour, which we have convert from the liter per second, and the fan power is 0.55 kilowatt. So the difference between the ASHRAE and the catalog is about 100 to 200 meter cube per second. Okay, so we're moving to the next slide. So this is the layout of the Apache HVAC. So as we can see, there's a lot of information there that we can change, but in this case, we will change only the airflow rate and fan power. So the HVAC system that we use is VAV with heat exchanger. So this is the result for my project. So this is case 1, where the airflow rate is constant, which is 1011.52 liter per second. So as we can see in the table, the ASHRAE standard fan power 0.7 kilowatt is much higher than the catalog fan power, which is 0.55. The ASHRAE standard energy consumption consume 103.2699 megawatt per hour, while the catalog 0.55 kilowatt only consume 103.066 megawatt hour. So the difference is 0.2, so that is not very significant. So in this in this graph, as you can see, the yellow dot is 0.55 kilowatt, while the blue dot is 0.7 kilowatt for the fan power. Okay, so this is the second case, case 2, where the constant fan power 0.55 kilowatt. Just now we have compared between the airflow rate 1011.52 and 1023.61 liter per second. So in that comparison, we find that the 0.7 is much higher than 0.55 kilowatt. So in this second case, we will use the 0.55 kilowatt fan power because it is lower than 0.7 kilowatt. And then we will compare between the airflow rate from ASHRAE standard 1011.52 liter per second and 1023.61 liter per second from manufacturer. As we can see from the bar graph, the green bar 102361 is from the manufacturer. It's lower than the ASHRAE standard. It's also you can see from the table that catalog is much lower, even though the flow rate is increased higher than the ASHRAE standard. So that's all from me. Thank you.